Hello students, welcome back to the next module of a chapter called electromagnetic induction. Now students, in the previous modules we have already discussed the construction, the working and the mathematical part which was related to working of transformer. Now students, using those particular formulas that we have learned in the working of transformer, we'll solve numericals on transformer in this particular module, right? So let us start with the first numerical of the module, right? It says the primary of a transformer has 40 turns and works on 100 volts and 100 watt. Find the number of turns in the secondary to step up voltage to 400 volts. Also calculate the current in the secondary and primary. Now students, on the primary side we are having 100 volts and on the secondary side we are having 400 volts. So I can say voltage across secondary is greater than voltage across primary. So this is nothing but a step up transformer, right? So we are provided with step up transformer and we are supposed to find the number of turns in the secondary coil. Then we are supposed to find current in the primary as well as current in secondary coil. Now let us analyze this and let us write down the given data. First of all, we are provided with primary of transformer and it is having 40 turns. So I can write NP, it is equal to 40. Right? So here I am having transformer and this primary side is having 40 turns. Now this particular primary side works on 100 volts. So I can say VP will be equal to 100 volts. So let us update this as well. So here we have updated that primary side is working on voltage of 100 volts. Right? Now let us move further. Now the power on the primary side is 100 watt. So I can say P suffix P, it is equal to 100 watts. Right? Now students, over here will assume it to be an ideal transformer, and in case of ideal transformer we know that input power it is equal to output power, or primary power across primary coil it is equal to power across secondary coil. Right? Now let us move further. Now in this case voltage is stepped up to 400 volts. So I can say value of Vs it is equal to 400. So on input side we are having 100 volts and on the output side we are having 400 volts. What we are supposed to find? In this case we are supposed to find the number of turns in secondary, that is Ns. Right? And then we are supposed to find the value of current in secondary and primary. That means we are supposed to find the value of Is and Ip. Right? So all these parameters are given and we are supposed to find these three things. Now let us write down the formulas that we'll be using to solve this particular numerical. The first formula, that is nothing but the equation of transformer, and we can write it as Vs upon Vp it is equal to Ns upon Np. And second formula that we'll be using is of ideal transformer, that is power across primary it is equal to power across secondary and it is equal to Vs into Is and it is also equal to Vp into Ip. Right? So these two formulas we'll be using. Right? Now let us move further. Now let us start with the solution. Now first of all we'll be calculating Ns. Now in order to calculate Ns we'll be using this particular relation. Right? So what is the relation? Relation is Vs upon Vp it is equal to Ns upon Np, and we can rearrange to find out the value of Ns. So this Ns will be equal to, right, it will be equal to, I'll transfer Np to that side. So what will I get? I'll get Np multiplied by Vs upon Vp. Now we know value of Np. What is the value of Np? It is 40. Right? So this will get 40 multiplied by, what is value of Vs? Value of Vs is 400. So 40 multiplied by 400 and value of Vp is 100. So this will become 40 multiplied by 400 upon 100. Now you can cancel out. After doing calculation, you will come across the value of Ns. Right? And the value of Ns in this particular situation is 160 turns. So number of turns in the secondary coil is 160. And what is the number of turns in primary? That is 40. Now see, we can relate to it, right? As number of turns in secondary is greater than number of turns in primary, this particular type of transformer is nothing but step up transformer. Right? Now let us move further. Now let us calculate the value of Is, that is current across secondary coil. For this we'll be using this relation of power and we can write Ps will be equal to Vs into Is. And what is value of Ps? It will be equal to 100 watts. Why? Because we have assumed that the transformer is ideal, or I can say power across primary it is equal to power across secondary and both will be equal to 100 watts. And this 100 watts will be equal to Vs into Is. Now from this I can rearrange and I can get the value of Is. I'll be transferring Vs on right hand side. So I'll get Is will be equal to 100 upon Vs, and we know the value of Vs as well. So this will become Is it is equal to 100 upon Vs and it is equal to 100 upon 400. Now what is 100 upon 400? This will come out as 0.25 ampere. Right? Now let us move further. Let us calculate current across primary coil. right? Now for this, we'll be using this particular relation of power. So I can say power across primary, it is equal to Vp into Ip or Ip into Vp. Now let us rearrange and get the value of Ip. So I can write Ip, it is equal to P suffix P upon Vp. Now we know power across primary. What is the value? It is 100 watts. Right? And we also know voltage across primary, that is also equal to 100 volts. So this will become 100 upon 100 and this will come out as 1 ampere in this particular situation. So I can say current across primary is equal to 1 ampere. And what was the value of current across secondary? That was 0. If you remember, right? So I can say current across secondary is lesser than the current across primary, and that was also the condition that we have learned in the types of transformer, and that too in step up transformer, right? So students, in this particular module we have covered one numerical which is based on the concept of transformer. In the forthcoming module we'll solve further more numericals which are based on the same concept. So that's it for this particular module. I'll see you in the next module. Till then, keep learning.